Hands up, hands up, hands up. If you with it.
What's up, T-boys and girls? Welcome back to Terminal 24/7. It's your boy CJ. You already know what it is. And who's ready for some object-oriented programming? That's right. We'll be diving into the world of OOP today. So if you like this content, smash the like button, hit subscribe, and let's get coding. Alright, so fire up Visual Studio Code because that's where we write our code in. Now, classes are basically blueprints for objects, and objects are a big deal in object-oriented programming. It's literally in the name. So classes, objects have properties and behaviors called attributes and methods. Let me show you what I mean. Let's get our hands dirty. Let's create a class called animal. Here we have it as a class. You're seeing it right there. But it doesn't do anything. It has no properties or behaviors. So let's start with defining a property. Let's say we have a type of animal, and we're going to have an init method, which is a constructor method, which will run as soon as you create an object from this class. So we're going to have to define what type of animal it is when we create a animal object. Animal. Let's say we'll have a wildlife animal here, and it's going to be the animal object wild. So the type would be a wild animal, and we have a homebred animal. Let's say it's homebred. So if we run this, no, we're gonna have to print it out first. So let's print out the wildlife animals type and print out the homebred animals type. So we'll see wild first, then homebred first. If we print it in the terminal, bang, you got it, wild and homebred. So that's the attribute of this animal class. So let's talk about inheritance. What is inheritance? Passing down attributes from a parent class to a child class, to a subclass. So we're going to subclass the animal class called, let's say dog. We'll have a dog class. It's not going to do anything. And I want a wildlife animal, let's say fox class. It's not going to do anything. Right. So if we say we have a dog object and it's a homebred, because dogs are home animals. We have a fox. It's well, mainly a wild animal. So if we print out dog's type and the fox's type, we have ourselves dog is homebred and the fox is a wild animal. That right there is inheritance. So this dog or fox classes are subclasses, child classes of the animal class. So this type attribute is being passed down. You don't need to redefine it here. This dog class and fox class will have a type attribute, the property of the class. So let's talk about polymorphism. We're going to leave dog and fox here. So let's define a behavior of this class. Let's define a method. We're going to have, because animals make sounds, right? We're going to have a speak method, but it's not going to be implemented here because we don't know what type of animal it is yet unless we define it. So here we're going to override this method speak, because we all know dogs go woof and dogs don't make the same sound as foxes, and foxes don't make the same sound as dogs, what does the fox say? Ring a ding a ding ding ding. That's right. And we're gonna make our dog and fox speak. Here we have a woof and ring a ding a ding a ding a ding. So that's polymorphism right there. So it's the same class being subclassed, but you have a different behavior, because dogs don't go ring a ding, they go woof, and foxes don't go woof, they go ring a ding. So that's different for each subclass, but they're from the same base class, from the same parent class. That's polymorphism right there. And there you have it, classes, inheritance, and polymorphism. Okay, so modules. So when writing code, you want to modularize your code into smaller, more manageable, readable, more understandable, comprehensible pieces of code. So in big complex projects, you might be working with other developers. It makes it easier for collaboration, or you might be handing over your work to another person. It makes it more readable and more maintainable. Or another person might want to improve on your project and makes it more scalable. So, all right, starting off, we'll modularize the animal class into another file. Let's say animal.py. Put it here, and from this script we're going to import from animal, import animal. So basically you don't have the animal code here anymore, you have it here, and you're importing that code into this file, and when you run it, you still have the same output from your code. So if we'd like to further modularize this code, we can create, let's say, an animals folder, and in the animals folder we'll have, let's say, homebred animals and wildlife animals. So we'll have the animal base class in the animal folder, and we're going to move our dog class into the home folder, calling it dog.py, paste it here, and in this animals folder we're going to need a init.py, which is basically a catalog to show what's available for import inside this animals folder. So from animal import animal, this dot right here is basically specifying that you're referring to a file in the same directory. So this animal.py is in the same directory as this init.py. So same directory, animal. Yeah. So in doc.py you're going to import animal here, because you're using the base class over here. You're subclassing it right here, so you need to import it. And we're also going to move this fox to the wildlife folder. Let's call it fox.py. We'll have to import that as well. From animals, import animal. And here, we're not going to import animal here anymore because we're not using the animal base class here anymore. We're only going to use dog and fox. So from animals.home, you see animals.home, you're going to import dog. And from animals.wild, wildlife animals, you're going to import fox. So this dog file, this is the name of the file, contains this dog class. So what you want to be doing is, you can either say dog.dot here, but that's going to be confusing. So we're going to do .dog import dog here, .fox import Fox. And there we go, clean code. So we have our code modularized over here. And you don't have to look back, you know where it is, you know what it is. You can actually just import it here, and when you run your code, you still got the same results. Woof, ring-a-ding-a-ding. So that's best practice to modularize your code always. Alright guys, so there you have it, double OP and some principles like inheritance and polymorphism, then modularizing your code into more clean, manageable, maintainable pieces of code, files, and folders as a best practice. So if I was unclear at any point, or you have questions or anything, feel free to drop a comment down below and I'll get right back at you. Otherwise, you know what to do, smash the like button, hit subscribe, and see you on the next one.